Welcome back, this is Josh, and today I wanted to go over solving inequalities, and I figured we might as well graph them at the same time since the graphing of the inequalities is kind of like a second part of this that you're gonna have to know how to do. So let's go through this stuff, and I'm gonna start small and kind of work my way up. Let me write a couple equations over here so that way if you wanna move ahead you can, and then I'm gonna get working over here. So let's do x plus 3 is greater than 5. 2x plus 3 is greater than 5, and negative 2x plus 3 is greater than 5. So as I said, we're going to solve the inequalities first, and then we're going to go back and graph them at the same time. And these are going to get progressively more challenging, so let's get started. With the first one here, we have x plus 3 is greater than 5, all right? We have our imaginary barrier. If you haven't watched my other videos on how to solve equations, really what we're doing is we're solving equations and now we're applying this greater than, less than, or greater than equal to, or less than equal to, because now we have this instead of an equal sign. So the rules of math still apply when it comes to that being a barrier as an equal sign. And so in order to isolate the variable, in order to get this guy out of the way, we have a plus 3. So as I say in my other videos, we got to get rid of it. In order to do that, we have to do the opposite. And so because it's a plus 3, we minus 3. I know that's not really the best way to say it, but what we're doing is we're subtracting, okay? You're doing the opposite because plus 3 and minus 3 gives us a 0. What you do to one side of the equation, you got to do to the other. So let's do that. 5 minus 3 is 2. We're left with the inequality x is greater than 2. It's important that you read it from the variable, okay? Even if you end up with the x on this side, still read it from that side in the direction, in the direction of the inequality, just so that you're able to graph it. If you read it backwards like 2 is less than x, that's really hard to graph because how do you know what x is? Well, it's 2 is less than x. Okay, so is 3 less than x? Is 19 less than x? You don't know. Unless you read it from the variable, it can be really challenging to graph these and to really do much else. So let me just draw my quick number line. I always encourage students when you're graphing them to add a 0 just so we have like a point of reference. And then we graph it as we read it. X is greater than 2. Now books teach this differently. I like to draw my inequality or my little starting point 2 right there on the actual number line. Some books will do it where it's kind of like a floating circle or a floating dot above the number line. It really depends on how it's being taught to you. Either one is okay. Just I feel like it's a lot easier when it's on the number line because it's very obvious this is where your number will start. When they're floating, I've seen students, not that your homework is that messy, but as you guys start making all these lines here, they're not straight. It's hard for me to tell where exactly is this thing starting. So if you make it on the number line, it's very obvious. We're working with the number positive 2. X is greater than 2, and so because it's greater, and if it helps to write in your plus and minus sign to remind you that this is greater than, less than, x is greater than 2, greater, so we would shade this direction and just make it like an arrow, okay? The reason I like this bubble so big is because then it's very obvious that x is greater than 2. If you shade in the bubble, now you're getting into new rules, and we'll get to that in just a little bit. So, looking back here, we subtracted 3 from both sides to isolate the variable, then we moved on to our final answer, and then we graphed. At this point, if you'd like to pause the video and try the next one, I say go for it. And if you want, just keep on following with me if you'd like. So let's get that next guy up here on the board. And really, it's the same equation. And a lot of times, this is how I like to teach this stuff because I feel like we start with something basic and I just keep adding extra stuff to it and we learn along the way. 2x plus 3 is greater than 5. Okay, well, we have our barrier here, as always. We need to isolate the variable, but you need to get rid of this guy first, as we did before. So let's subtract 3, 0, and subtract 3, and we get a 2. So what do I have left on this side? That guy, and on this side I have this guy. the inequality just moves down. So I have 2x greater than 2. All right. Now in this situation, we have 2 units of x instead of 1 unit of x. And so really the only way to get rid of that, hopefully you've watched my videos on solving equations, but in order to get rid of it, we got to see this as 2 times x. And because it's a 2 times x, we can do the opposite of multiplying to get rid of that number next to the x. So we, rather than multiply, we divide by 2. That way these can cancel. What you do to one side, you got to do to the other. We read our fractions down. So x is greater than 2 divided by 2 is 1, right? All right. And then we got to graph it. So I'll just kind of use some space over here. And these are just good practices, okay? By putting in a 0 in the middle, you're just showing your teacher, hey, like I understand where this number is. If you're just writing floating values in here, it just gets sloppy. So take an extra second, put in a 0, and then move on. X is greater than 1. If it helps you to, again, write the plus and minus, then do so, right? That's going to remind you greater than, less than. X is greater than 1, so I'm going to make my big circle here, my bubble, and a number 1, and x is greater than 1, so off we go in the greater direction. And that's about it, okay? So now we've worked through 2 problems, and I'm going to start with this third guy here and graph that one. Well, solve it, I guess, first, and then can't put the cart before the horse. I'm going to write this guy a little bit farther over. Negative 2x plus 3 is greater than 5. Same thing, right? We do those first same steps. We subtract 3, we subtract 3. Now we have negative 2x is greater than 2. Same as the last one, right? Except for this negative. And I wrote it with a negative for a reason. Let's divide this side by oops, that guy's dying. Negative 2, and what you do to one side, you do to the other. Let me toss that. And we read our fractions down. Negative 2 divided by negative 2 is 1. So we end up with an x. And over here we have a 2 divided by a negative 2, which will give you a negative 1. Okay, now there's a couple proofs and theorems and rules and all that stuff that explain why this happens. And so maybe if you guys really want to know, I can make a separate video on it. It can get a little bit complicated, but the basics of the rules say that when you multiply both sides or divide both sides by a negative value, okay, like we did here, the inequality sign here or symbol changes direction. It's only when you multiply and divide. If you're adding and subtracting, you just add and subtract just like I did here. The inequality sign stayed in the same direction, right? It didn't do anything. But when you multiply or divide, it does change the direction. So you've got to remember that one little tidbit right there, because when it comes to graphing, you might end up graphing it in the wrong direction if you don't do it. I'm going to put in my 0. Negative 1 is my starting point, so I'll just put it back over here. In my class, I'm not very particular about like, is this negative 1? Like, you know, we don't need every single number on the number line. I just need to know that your answer is negative 1 and see which side you shaded, okay? There's no need for you to draw in all these extra, you know, little lines here and count and everything. I'm usually okay with that. Again, if your class or teacher teaches it the bubble method where it's floating over the number, just be a little bit more careful so you know it's right on top of the value that you want. And it's less than, right? X is less than negative 1. So we would shade in the less direction and go that way. Okay, so we've done 3 different situations here. I want to do 2 more that are just going to kind of trick things up a little bit and wrap it on up. So let me clear this and this actually, and get these 2 equations up over here. So if you want to be ambitious and try it, I say go for it, right? X plus 3 is greater than or equal to 5. Negative 2x plus 3 is greater than or equal to 5. All right, what I did was I changed the inequality sign to a greater than and or equal to. And hopefully you've had a lesson on inequalities. If you haven't, I think I've already made one. If not, maybe I need to do one. But greater than is different than greater than or equal to. And hopefully you know that by now, so we can solve this guy. x plus 3 is greater than or equal to 5. If you think you know what to do, I say go ahead and do it. Pause this video, see what you get, check with me, okay? Gosh, same problem, so it shouldn't take me too long. This is the barrier. We subtract 3, which you do to one side, you do to the other, and get a 2. So x is greater than or equal to 2. I like to say it out loud, and I encourage you guys to say it out loud because that's what's going to help you not make mistakes when it comes to graphing these guys. All right, let me put in my 0, and my starting point is a number 2, so I'll just go out over here and make my nice big bubble. X is greater than 2. Awesome, okay? But x is also equal to 2. And so because of that, in order to fulfill these requirements, x is greater than 2, got it. X is equal to 2, you shade the bubble. And so then it becomes a dark bubble like that. And that's how it should look. If you're doing the floating ball lesson, it should look like that, kind of right on top of the 2, but it definitely should be shaded. And one thing I always recommend to my students is make these bubbles nice and big so that your teacher can really see that it's either shaded or not. If I have had students that, they make it kind of like that, and then they shade through it like that, and I'm going like, is 2 shaded or not? And then I have to go ask them, and then they're gonna tell me what they think is the best answer. So make it very obvious, okay? You don't wanna lose points or lose credit just because you got lazy and didn't take the time to draw a circle. If you're pausing the video and working through it, then awesome. This next problem here is very much like the one we already solved. There's one extra little trick that we just kind of practiced. So if you want to stop and try it, I say go for it. I'm going to work through it right now. Negative 2x plus 3 is greater than or equal to 5. Gosh, I feel like I'm doing the same step over and over, but that's okay. Minus 3. Negative 2x is greater than or equal to, oh, that's awful, is 2. You can tell that's a 2, right? Right. Okay. We do the same thing, isolate the variable. We divide by negative 2, divide by negative 2. This all cancels out, and we're left with x. 2 divided by negative 2 is negative 1. We divided by a negative sign. And so again, the rules of math say you got to reverse the direction of the inequality. Now we can graph. Let me draw my line. Let me draw my 0. My starting point is at negative 1. And as I said before, notice that this is just kind of off on this side, okay? At least in my class, I encourage students, as long as you put it on the left side of the 0, then I know it's at negative 1. I'm not going to measure with a ruler and say, well, you're not making this straight, because there's no other lines on this x-axis or whatever you want to call this anyways. So it doesn't matter. All that matters is that you're putting it on the right side of the 0 and you're shading in the right direction. That should be the core of what you're trying to learn right here. And that should be the only thing they're really criticizing you on. X is less than negative 1. Okay. So we would go in the less direction, right? Remember, we have less than, greater than. If you want to write these in to always remind you which direction to shade, then go for it. If you do this and you read it from the x out loud to yourself, you really should not be making mistakes. X is less than or equal to negative 1, less than, and equal to, or equal to. Sometimes you'll have to write it out as both. Okay, and so once we have that shaded completely, if you're doing the other method, it's more of a solid thing here, and then you just shade out in that direction, and you're all set. Okay, so watch the video again. I know I went kind of quick, but the rules of isolating the variable, you should be solid on. At this point, you should just be taking in the new stuff, which is which direction to graph, whether it's shaded or not, and whatnot. And then a couple little technicalities of how to make these look nice and neat. Thanks for watching. Subscribe to my channel, ask questions. Thanks.